It runs good. It all
If you just get the oil pressure,
Yep.
you're right.
Yeah, well, the oil pressure gauge, the oil pressure is right, but the gauge is unreliable. So that's why we're going to master gauge it and all that.
Yep.
But all that kind of change stuff.
I was going to plug that thing in this morning before we come in here if y'all weren't already in here.
All right, what did that job do to your confidence in being able to do something pretty intrusive? Because that was a heavy duty job. That's a job they would have given the top guy.
I felt pretty good about it. I never took a transmission out or put one back in before. I took one out.
So you got that. You pull the transmission, you yank the engine, you pull the front off of it. You put the time and change stuff, like $400 worth of time and change stuff on the front. You lined it all up. And see, the thing about it is when you're working on something that matters, one of the problems with working on trainer cars, and you guys listen, one of the problems with working on trainer cars, now Chelsea's doing something I've needed done for a long time, so I'm not taking apart trainer car work. I mean, there's some other stuff like that needs to be done around here too. That transmission
I want to rebuild 350.
Yeah, it's already been done. I mean, yeah, somebody's already rebuilt that one, but that was too easy anyway. You'd be able to just go things. Yeah, but anyway, so Archie, you got. So what have you been working on all semester? Different transmissions, right? You put a clutch. You put a clutch in the. You put a clutch in the Toyota, and then you have fight with his Blazer over here, right? And you've also been doing some other stuff too. Chelsea did an oil cooler in a Saturn, which was no small feat. It's a booger bear. Yeah. See, I put Sean and Chelsea together doing the oil cooler in the Saturn, and Chelsea puts the elbow to Sean and shoves him out of the way when they do anything. So Sean has to get something else. You know what's funny about that? Usually when you put a girl and a guy together working on something, the guy elbows the girl out of the way and does the work, but this time it went the other way. But Wes is has had an illustrious career already. And we got the 07. We got to get that transmission, we got to get the pan off of that one and see if there's anything in the pan. That's the first thing we're going to do. Incidentally, I got the Ease diagnostics scan tool to talk to the engine controller. Well, I did. I mean, what I'm saying is it will communicate, so there's not a communication problem. It must be some sort of a disconnect between it and the other scan tool we were trying to use. Let's go ahead and go with this test right here, Powertrain Fundamentals Test 6, and we're going to be talking about some computers, some modules, some serial data, and then transfer case and one thing and another. I mean, it's just part of sort of a
hodgepodge. Make this instructional video before the end of the semester?
Yeah, you need to do that.
Seriously? I mean,
yeah, you need to make one. Figure out something that you can. I need you to make one that I'll be able to show other people they'll learn something from.
From the time of blood, I don't know if I ever do it again, but
you know how much it's a lot of trouble. You got to talk while you're doing it and look at the camera. Now I've been doing most of the talking on Chelsea's video, so that disqualifies that video for her. She's going to have to do the talking. Okay, all right. You got to do a different one. PM sensors measure the speed and position of rotating parts. What's a PM sensor?
Parts moving.
What is a PM sensor?
Maybe it was a permanent magnet. You think?
Oh yeah.
Permanent magnet sensor.
That's true.
Remember how I told you those permanent magnet sensors work? If you had to design one, what would you do? What you gonna do with? How you gonna design? I'm gonna get me a doggone marker. Let me see what marker I've got.
Yeah, boy, go get you one. I need your pen, man. Sit here and hold my hand out 10 minutes.
I was just heading off 10 minutes. What's you like that, Brad?
Man, you're going to stuff your fat ass in the trash can. The camera ain't on, but...
It is. Sabotage that car.
It never fails that when I'm in class, somebody always wants to come in here and talk about something. Okay, now then, what I got right here, I've got if I'm doing a permanent magnet sensor, I'm going to make a cylindrical thing like this. Then I'm going to wrap wires around it. Lots of them. Round and round and round and round and round. Yeah, I gotta erase that so it'll look like some of the wires are going around it, some of them are, or whatever, you know. Anyway, then I'm gonna, every time I go past that sensor with a tooth, the magnetic field is gonna shift back and forth. And when it shifts over that copper winding, it's gonna cause a signal to be created that looks like that.
Oh, that was square wave.
Huh? Not unless it's a Hall effect.
Okay.
On a sensor like you see on that front of that.
Huh?
The crank angle sensor like you see on the front of this little vehicle right here. See that? That little crank angle sensor, you notice how it goes past those teeth, is actually going to be creating a signal. Now, that's got a missing tooth on it, and that missing tooth, I tell you something else that I like to do in engine performance is I like for you to analyze where in which stroke that missing tooth is. And a lot of people will try to say top dead center compression, but that's not so. It's not. It's several teeth away from there, okay? Basically, usually when you've got a missing tooth or something, it's going to be coming up. All right, now then, the resistance of a PTC thermistor increases as the temperature it monitors decreases.
Positive coefficient.
Positive temperature coefficient. Now, does the resistance of that positive temperature coefficient thermistor increase as the temperature it monitors decreases? In other words, as it gets colder, does the resistance increase? No, it doesn't. That's a normal, like you would expect the temperature, the resistance to increase with temperature. That's positive temperature coefficient. But if the resistance decreases when it gets colder, then you're basically, what are you talking about? If colder is more resistance and hotter is less resistance, that's negative temperature coefficient, right? Okay, so that number 2 is false. An analog signal continuously and smoothly changes. Look at that. Wow. And I would say changes. Let's look at that way the question is worded. An analog signal continually and smoothly changes in. Changes in. I wish you would change that to a Facebook pop or something instead of.
I'm gonna turn it off.
All right. An analog signal. What does it change in? What does an analog signal look like? And what is the difference between analog and digital? It's a sine wave, right? Like that.
What's the digital one look like?
Digital one looks like that. Off and on. Yeah, got it. That's digital. Digital is off and on.
So what's number 30 then?
Yeah, analog is that. So. Well, think about that. Interesting. Number 3 is actually true. They continuously and smoothly change. Basically, if it's analog. What kind of a sensor signal is a throttle position sensor signal? Huh? I mean, is it analog or digital?
Analog.
Analog, because it can read anywhere between about 0.6 of a volt to about 4.5 volts, right? So that's an analog signal.
Why do they say it's a 5-volt reference to it then? If it only, mine only go to 4.5, like you're saying.
Well, because it's not going to go all the way to the end. You know what I mean? You've got, for instance, it's going to have even when you hit the end, it's still got a little bit between there and all that. But it's got 5 volts now. On the temperature sensors that only have 2 wires going to them, they only got 4.6 going out to them usually, because there's a little resistor inside the PCM that drops the rest of that.
Right.
So that's basically like it too. Huh? Yeah. All right. Then automotive computers and control modules use analog signals converted from digital signals. That's false. It's the other way around. Most of the time, if you've got a sensor signal that's coming in as an analog signal, it's going to convert that analog signal to a digital signal. Now, the old GM map sensors and stuff on computer command control cars that had feedback carburetors, they had the woman at this General Motors Training Center said, computers don't like analog signals. That's one of the first times I ever heard anybody talk about that. Who had a personal computer sitting on their desk in 1980? You weren't even sitting on the desk in 1980. But Sean probably was, but he was a real young whippersnapper. But anyway, but the point, long and the short of it is, they said they don't like analog signals, so it's going to have to change it. So what it does is they can program the computer this way. They watch the voltage of an analog signal, and when the voltage of an analog signal goes up to a certain level, when it goes up to this particular point, if the computer says, okay, that's on, and as long as it stays above that, the computer keeps saying, okay, that's on. When it drops below that threshold, whatever it may be, then like let's say that threshold was 2.5 volts. If when it drops below that threshold, the computer says, okay, that's off. That's how it converts it.
Oh, okay.
See what I'm saying? It's not that hard to figure out. I mean, you just got to type an algorithm and make it happen. And they got these little chips that convert it and stuff like that.
Right.
An entire PCM must be replaced if a change in programming is needed and the PROM is not replaceable.
That's true.
Well, yes,
Well, I mean,
but
yeah,
don't. This is an old question. I mean, it's a question about old stuff. On an engine controller that, like a Ford, the old Fords, like the one in the Bronco, it's got 60 pins. You could not reprogram those because they did not have a flashable chip in them. It's an EEPROM, they call it, an erasable PROM. And what happens when you got an erasable PROM is that and whenever you're going to reprogram a chip in the computer, the PROM gets 18 volts sent to it through the data link. That's scary, isn't it? You're juicing up 18 volts going through there, and when 18 volts hits that EEPROM, it turns blank. Boom. All right, and then you're charging it back up. Well, what was funny to me was when I was at that school up there, those guys that were the instructors at the hybrid school had a battery, right? The battery's got a computer that's built in with the battery on them hybrid vehicles. Okay, so they had been doing a reprogram on that thing, a reflash, and somehow during the middle of that reflash they had a power glitch or something. I don't know what happened, but they lost that computer. I mean, they couldn't wake it up, they couldn't reflash it, they couldn't talk to it or anything else. And so there's this guy named Joey Hendrick, big heavyset guy that was from Russell, Kansas, and his specialty was programming. Matter of fact, he was at that school because the guy asked him to come. You know, Craig asked him to come because he was a super duper programmer. And so he says, "Can you do anything with this computer that we fried in this battery?" And he said, "Well, let's take the battery," because it was a trainer battery, and let's take the battery. The battery's underneath the cargo area. It's a huge thing, you know. Let's take this one out and let's put that one back in there, plug all the wires into it, and we got it all plugged in there just like we were going to use a car. And then he sat down and he hooked up his laptop with his Ford IDS system on it, which is like the scan tool part of the Ford. And he ran another program in the background. And so whenever he plugged in and went, and it queried all the modules. And then he went to this log file, and he's dragging his finger down this log file. And one of those instructors says, "What are you doing?" He said, "I'm trying to see what the protocol that this battery control module speaks, and if I can figure out what the protocol is, I can go in through the back door and I can save it." And they were just totally like deer in the headlights. I had no idea what he was talking about. And did you know that knothead went in there and did that? He went in the back door of that doggone thing and he fixed what they had fouled up and saved that battery controller. I mean, see, that it wasn't physically damaged. It was a programming problem.
Right.
And that's how sophisticated this stuff is nowadays. You can buy a programmer, and I've held one in my hand and used it, these little super chips. Little red thing, it looks like a scan tool. You can buy this specifically for your vehicle, and you can plug it in, and you can change the program
Like a
back and
pulley dog.
forth. Huh?
Like a pulley dog.
Yeah. And what you do is you can say, "I want to pull a trailer, or I'm going to get good gas mileage, or I want this, or I want that." It's got several different programs. Now you're not going to go in there and change everything, you know, like a menu. I want this much more spark advance and that much more fuel
Hey,
pulse.
there's something you can do that.
There is, but you're going to screw it up. I mean, I've seen people trade vehicles in that had those, and they'd trade the thing in, lay it in the doggone console because they'd messed the truck up so bad that it wouldn't run right, and they didn't know what to do to fix it. That's kind of like a little kid getting in there playing with the keyboard on your computer. Have you ever had somebody hit the wrong keys on your computer and change something on the screen that you couldn't figure out how to fix? Like little kids will do that. They'll just slap the keys a few times. And my son Luke is an IT guy that's really sharp. He said, "I'm going to have to reload this machine because Connor did something. I don't know what to do to fix it." I mean, it was just totally fouled up, and he just did it just randomly slapping keys. You know, so that's what you're going to do if you get in there and try to change that stuff. That's the people that are experts at that have really studied it a lot. They know what the sound hell they're doing. I wouldn't go there. You know, if it was a vehicle that mattered. If it was a trainer vehicle, I might go there. But anyway. So, and we can reflash PCMs out here, and I'm going to show you guys that when we get into advanced engine performance. All right, now then, a shift solenoid. Now, number 5, if you want to get that one right according to the answer key, is going to be true. That's an antiquated question, though, because you can reprogram the engine controllers nowadays. Ever since OBD2 came out, everything had to be reprogrammable, right? That's when it started changed. A shift solenoid can be tested with a digital voltometer or by air testing.
Yeah.
That's true. You can check it to see if it's got good Yeah, you know, and see, neither one of those, well, particularly if you air tested, it's more reliable, because if you energize it and blow, and you can blow through, you know, energize it and it changes whether you can blow through it or not when you're clicking it back and forth. You start blowing through it and you like that, then you know it's good. You check it with a digital voltometer, that's okay, but you're not really going to know if it's mechanically operative. Occasionally, now listen to this because this is important. Nobody miss what I'm going to tell you. You're going to occasionally see codes that are going to talk about a performance fault on a component. Like it'll say 2-3 shift solenoid performance. Have you seen that?
I seen it one time.
It's a performance thing. What does that mean? It means I don't see anything electrically wrong with the solenoid, but when I told it to go from second to third, it didn't go from second to third. Even though I see that there's voltage coming through that solenoid, and when I energize it, that voltage goes away and it's not a short, but the solenoid obviously is not doing its job mechanically because I'm not changing gears. And that's why it'll tell you that. Anytime you see a performance fault, it's going to mean I told the solenoid to do what it was supposed to do, and it didn't do it. That's what that typically means. That's what that means to me, and I've found that to be, All right, so vehicle sensors produce an output signal that can either be an analog or a digital signal. Excuse me. Give me an example of a digital signal on a vehicle sensor. What sensors have you seen that put out digital signals? That's one. What's another one? Hall effects is a no-brainer answer, which is it's a good no-brainer answer, but it's a no-brainer answer. Come on. What else? In transmission, last time we were talking about digital transmission range sensors. What do those signals look like, guys? What does an analog transmission range sensor have in it? Heck, it's got like a throttle position sensor wiper. And when you put it on a scope and you go click, 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 click through your gears, you're going to see stair steps. With each one of these park, reverse, neutral, drive, or maybe the other way. Yeah, that's the analog. Now, what we used to do is we would click it through with the thing showing on the screen. And a lot of times on some of these, like on that, some of the cars that were like Taurus is similar to the ones Chelsea's working on at Sable, we would see, instead of this being nice and crisp and flat, we would see this kind of nonsense right here in between some of the steps. And if that's the case, you got a bad sensor. You throw a sensor on it, $67 plus 2 hours labor for your diagnosis and your replacing it. See that? Huh? There you go. But you can actually connect that scope out there that I've got to the right wire. You hook the scope to the ground, you hook it to the proper wire, you click it through, you look at your pattern, you freeze it, you study it. All right, now watch this. Do you remember? Can anybody tell me? Any of you guys from last time? Everybody remembers binary math, right?
Yes.
Remember the binary math thing?
The binary code thing.
Yeah, binary code thing. So you're going to have on binary code. You've seen the on/off switches on your equipment. It's got an I and an O. What's I?
O.
An O. That's actually a 1 and a 0. It's not an I and an O. So basically, if you turn it on, it's a 1. If you turn it off, it's a 0. Imagine yourself. Now listen. Imagine yourself.
I said on for I.
It is.
I know that's what I said. You
Yeah.
asked. I said on. And then you said something about.
No, the I is actually
Oh.
1. The I is actually 1. It's not an I. It's a 1. That's where I was going with that. All right. Imagine this. You've got 4 switches. Like this right here. Uh-oh. I messed up that square. I should have cut and pasted it in paint or something. Okay. Okay, now you can have it on or off. Any of these can be on or off. As a matter of fact, in some of your little computer stuff, they call these dip switches, and there'll be 8 of them. And they're little bitty things down in there. What was funny to me was one day I was working on the dip switches on a board in one of these computers that I was doing for diagnostics, and you had to set them a certain way. And I was doing these dip switches, and Sam, one of the students, said, "What's up with a dip switch?" And I said, "This is a binary code thing. You got I and O is on and off." He says, do you got a minute to explain binary code to me? And I started to talk, and the girl that was in here, Christina, was homeschooled. And she said, "I can explain it to you." And she got up on the board, and she taught it better than I could have. She understood binary code. She was about 18 years old. But she was homeschooled, and her parents had taught it to her. But listen to this.
Yeah, homeschool.
Watch this. If you click that, see, these are going to have a value. They're going to have 1, 2, 4. What's that one? 1, 2, 4. What's that one going to be?
8.
8. Big time. All right. 1, 2, 4, and 8. All right. So if I turn that on, this one here, you're going to count that one. If the rest of them are off, the value of that particular switch position is 1. If I turn on this one and that one, what is it? It's going to be 5. Got it? If I turn on that one, and that one, what is it? 7. Got it? See what I'm saying? If I turn on these 3, you're not going to count that one because it's turned off. Now, that's how the transmission range sensor works. You've got 4 switches in there. And every one of those switches can either be open or closed, or they can be open or closed in any combination. And with this binary code like it is, the computer is going to look at that number, whatever that binary number is, and it knows what's park and what's neutral and that's how that works. And but that's a digital sensor. So an analog one is like a throttle position sensor or whatever. Let me ask you this: is an engine coolant temperature sensor digital or analog? Everybody's so quiet.
Analog.
I say digital.
Well, is it just on or off?
I say it's analog.
What about what about your oil pressure sending unit you guys are fighting with? Is that digital or analog?
That's analog.
That's analog. What if it was turning on a light?
Be digital.
Bingo. Digital is on or off, and analog is the other. Now, some throttle position sensors have got an idle switch and also a sensor, so it's a combination of digital and analog. Okay, all right, let me see here. OBD1 technology can diagnose and detect only system failures and system degradation.
Degradation.
Degradation means that it's getting bad. It's going south. It's wearing out.
No.
That's false. But what they do on a lot of your later model OBD1 stuff, like in the mid-'90s on the ones that hadn't gone OBD2 yet, they actually had rationality checks. Like if it said, if I'm opening up the idle air control, I should see mass airflow increasing, and I should see engine speed increasing. So it opens up idle air control, and it doesn't see an engine speed increase or mass airflow increase. That's a rationality check, and it knows there's a problem with idle air control. Because it's like a performance fault. I'm telling the idle air control to do something, and then it's not doing it. So I'm going to throw a PO5 something another code, or PO15 or P15 or whatever. Because the 500 the 500 series codes in your series like PO5 whatever, every one of those is going to be speed related. You remember that? Huh? The PO or P15, if the third, if that first digit on that 3 thing is a 5, it's going to be something to do with engine or vehicle speed. See what I'm saying? All right. Now, what about 3? What about 4? 4, this is weird. 4 is going to have something to do with air, EGR flow, vapor management, something like that. See what I'm saying? That's strange how they put those. You're going to need to memorize those because there's going to be a pop test on it tomorrow morning. Okay, so look that stuff up, and I want to know if I'm going to say if I've got a PO2 series code or a PO3 or PO7. Hey, what's PO7 series code? Transmission. Anytime you see that digit at a PO7 or a P17, with the last 2 digits being whatever, that 7 is going to be a transmission code. This is taking a lot of the mystery out of that now, isn't it? You getting that? Got that? What about PO2? That's got to do with fuel injectors or fuel system stuff.
PO3 is misfire.
Yeah, and what else? Oh, what about what's a PO340? Cam sensor. Think about that.
Why is that one still under like a? I thought.
Good for you. Research project. Let us know. Look at it. You can make it.
Does it have to do with the firing of the plugs?
Yeah, it's got to do with the ignition system.
Okay.
Maybe.
Yeah.
All right, but see, fuel injectors are the P2. Ignition system stuff is P3 stuff. See what I'm saying?
Right.
Yeah. So P4 stuff is to do with air. P5 is to do with speed. And so on and so forth. There's a whole plethora of those we could talk about. And actually, I spent longer on that than I need to. Chelsea's over there just turning it into a skeleton. She's about to croak because she wants to start that Sable. That's what it is. Okay, serial data can be used when a no-code condition occurs. Serial data can be used when a no-code condition occurs. What is a no-code condition? Define that. Here's what I'm talking about. A no-code condition is when the customer comes in and says, my car runs like crap at road speed. So you drive it and it's bucking and jumping and cutting up. And you pull up your codes and you got no codes. You got a problem, but you got no codes. There's a host of people out there that are wanting to be engine performance specialists now because they feel like all they got to do is pull a code, change a part, and put it out the door and get paid big bucks. Wrong. Anybody that's been here with me very long knows better than that nonsense. Because it's not as simple as pulling a code, throwing a part on. You might pull a code, but now you're saying, what the Sam Hill do I do about this code? Well, what if you don't have a code? That's bad news, isn't it? I got this little thing I can plug in under the dash, and I can go drive it for all weekend and come back, and I can pull up every time they drove, and I know how far they drove. I know how fast they drove. I know how hot the engine got. I know how deep they went into the throttle. I'll probably put that on Shelby's truck. How about that?
They don't mind.
Shelby. I'm calling her Shelby. I'm gonna put a sticker on her head that says Shelby, so I'll remember to call her Chelsea. I don't know why Shelby rolls out of my mouth when I want to say her name. Okay, automotive transfer cases can either. Now we're back, guys. We're going into 4-wheel drive, so pay attention.
Number 9 was what?
We don't like
Number 9 is true. And number 8 is false. Okay, automotive transfer cases are either single speed or double speed.
Would that be true?
That's actually false. You're not going to have a single speed transfer case, really.
I guess not. I don't know.
Yeah.
I guess.
So how do we get an additional speed out of a transfer case?
Never took one apart.
Planetary gears, man. You know how that works. In a transfer case with electronic controls, the actual shifting is done with stepper motors or vacuum motors. In a transfer case with electronic controls, the actual shifting is done with stepper motors or vacuum motors. That is true. Hard shifting or jumping out of gear can be caused by a bent shift linkage. That is true too. How many of you guys have ever seen a bent shift linkage? You have. What bent it?
Bennett?
Yeah, what bent it?
Slamming it in.
All right. Not good. The first step in removing a transfer case is to drain the lubricant.
True. Well, you can.
Well, according to our the illustrious writer of our test, that's false, huh?
I didn't do it. I ended up with a really big mess too.
Yeah.
I didn't know any better.
Well, actually, I'm going to tell you the truth. I haven't pulled a transfer case. I mean, I haven't drained the lubricant before I pull the transfer case. But I tell you what, pulling a transmission, it's a good idea to drain the fluid before you pull it. Drain the fluid out of the transmission before you pull it out. Transfer case, you're not as subject to spilling any oil out of that, really. I mean, you can drain the lubricant if you want to.
Unless you were me.
Yeah, you have a penchant for that. Okay. The first step in removing a transfer case to drain lubricant, that is going to be false if you want to get it right. The outside of a transfer case should be cleaned before disassembly. Now, that's obviously true. You don't want to pull something that's got sensitive gears and stuff down in there, all the pieces, and let pieces of dirt fall in there.
Yeah.
There is a guy that was in the program here, and he was working on his own pickup truck. And he was, and it was a Ford pickup that he had a 91 model, little blue and white short wheelbase 302 AOD transmission. Anything else you want to know about it? Anyway,
Yeah.
it didn't have white wall tires. Gear ratio on the rear end was 355s, but one of the headlights was out, but we fixed that. Anyway, the point is, whenever you pull he did something. He pulled the dipstick tube out, and he lived on a dirt road, and a bunch of dirt fell in the pan. And he didn't catch it or didn't think a lot about it or whatever. He should have cleaned it first. Because he was working on it in the truck. I can't remember why he pulled the dipstick out unless it was leaking around that O-ring. I don't remember. One way or another, he had no problem with the transmission except that leak or whatever he was fixing. When he put it back in there and he drove it, it would shift up into a higher gear. It wouldn't shift down. It wouldn't shift. It would do all kind of crazy stuff. And bless his heart, he had to pull a valve body off that doggone thing and clean it about a half a dozen times before he could ever get it where it worked right because of that stupid dirt that got in there. This stuff, you can't put dirt in there. You know, it's not going to work. And this is not like a Winchester lever action rifle you can hold under a mud hole and cock it back and forth and then still fire it, you know. This stuff is a lot tighter tolerance than that. When overhauling a transfer case, replace all bearings whether or not they show signs of wear. That's false. You're not going to, if the bearings are typically, now, some of the, like in a rear end and all that, or in a transmission, gears can be noisy and look good, but bearings are going to be something you can tell if they're bad. You can look at a bearing and tell it's bad. If you look at a bearing and it's smooth and rolling and all that and it's not coming apart, chances are it'll be just fine. How many of you know that a transfer case has an oil pump in it?
Oh.
Yeah, the transfer case has got a daggum oil pump in it.
All of them?
Yeah, the ones that I know about do. You may, if I said all of them, you'd find one that didn't, and then that'd look silly.
I would.
But what? I got one over there that we tear apart and put back together. Incidentally, that's the next worksheet you guys are going to get. You got to tear a transfer case apart and put it back together, and it has to work when you get through.
Didn't we have to do that in automatic transmissions or
No,
manual
you
transmissions?
did.
Did you tear a transfer? Did you tear a transfer case apart and put it back together?
We have a transfer case. My bad. Never mind.
Yeah, transfer.
No, what it was is he had a worksheet and he didn't do it. Oh, so he gets.
Oh, is this? My bad.
No, that was not. Now, transfer cases for 4-wheel drive, right?
Yeah,
But I got a couple of transfer cases over there that we pull apart and put back
I'll
together.
do one.
And you'll see an oil
You gotta get
pump.
a blazer in first, aren't you?
You'll see an oil pump in
I
there.
gotta do your truck.
Now, don't wander around the shop today and ignore the blazer. It needs to be worked
I
out.
Damn it, Archie.
Yeah. Archie got the torque converter. Why was he having trouble getting the torque converter bolts back in?
Isn't it?
He was sticking the bolts in the wrong hole. There's a lot of holes. There's a lot of holes on that flywheel, and the problem is on that silly blazer, that 96 blazer, you can barely see what you're doing up in there. And
You
you can't.
can't see nothing.
Yeah.
Hardly.
And all that. But what we did was we looked with a mirror, and the original hole that we thought we were supposed to use didn't even have any signature marks where there had been a bolt. And so I found the ones that did have signature marks, and that's how we figured out which ones to use. And you know what? After he says, I'm going to get these bolts in. I've been working on this thing in an hour. Well, when I went over and looked, we worked it around. I said, look, that bolt's got a signature. That hole's got a signature around it where there was a bolt. And when we turned the torque converter up, lo and behold, the little boss lined up. Then incidentally, hey, Wes, you know the little hole where you pop that silly little tin cover out of those 4L60Es? You know what that hole's there for? So you can turn the torque converter.
Oh, I turn it. I pull the thing off with bullet.
Yeah, you can do some of that, but I mean, it works well for us. Whenever you want to turn the torque converter, you can turn the torque converter while you're holding your bolt through that whole other, maybe some other reason.
It does make it easier.
Yeah, and that's the other. I'm sure there's another reason for it there
Hey,
too.
but once you get
Yeah.
one bolt in, it's easy to get rid of.
Yeah, that's right. I'm just stirring up trouble right now. So
I know you are.
is that a good time? All right. So went over. Let's say, 15 was false. When reassembling a transfer case, check critical clearances with a feeler gauge, micrometer, or dial indicator. That is a no-brainer answer. You know you're going to be checking clearances. Always follow that too. A stepper motor moves its output shaft in increments such as a quarter turn or a half turn. Well, it's not going to move it a quarter of a half turn. It's going to move it in increments, but the increments are very small. Does anybody know what a stepper motor is?
No.
You know what a stepper motor is? All right. Have you looked at some of your idle air controls and you see it'll say it's got so many steps?
Oh, okay.
See what I'm saying? All right, now what is a step? All right.
Speed.
Imagine this. Imagine that you've got a screw right here that's going to do your work out here. It's got a little head on it, and it's got threads on it. All right. And on those threads, you have, threaded through there, you got this thing. Now, this shaft is fixed with a little ear on it, and it's riding in a slot so that the shaft can't turn. But you can actually turn this, and because of the fact that you can turn this, that shaft will go in and out as you turn that.
Hey, that's something like a electronic dog body?
Not really. A stepper motor basically a stepper motor has got some little windings. It's going to usually have 1 power and 3 grounds, or 1 ground and 3 powers. And it's going to have one of them, the hardwired, the one that's by itself will be hardwired, and it walks the other ones. And if it just touches one of them with a ground, this is going to move about that much. Now watch what I'm telling you now, because it's important you understand this. All right, so imagine my pin being this thing right here that's going to turn around that screw and move that shaft. Okay, whenever I touch, and this is, if you looked into that connector, you're going to see this and you're going to see 3 more. Let's say this one here is hardwired to ground, and it's putting power to these. Okay, every time I put power to one of those, this is going to move a little bit. I put power to the next one, it's going to move a little more. Put power to the next one, it's going to move a little more. If I want it to move a lot really fast, I'm going to, have you seen the turn signals on the new Mustangs that go boop, 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 boop? Okay, we're going to do that with these right here, and we're going to say this is going to turn like that. And it's going to turn reasonably fast. This is going to go, see that? So if you're able to stop this anywhere you want to by just stop sending the signal. And that's the cool thing about it. You don't have to hold it against spring pressure. You just stop it wherever you want it to be. You got that? Everybody understand that? Understand the stepper motor. Sean, you got it? Yeah. If I have you up here and explain this, you need to do it. Explain to somebody how a stepper motor works. See what I'm saying? you go over and see Michael today if you got a minute or two to talk. So he explained us how a stepper motor works. See if he did it
Find
right.
it one more time.
All right. Right here you got this one hardwired around. Then you got these right here. And you can either ground just one and the next one and the next one, or you can do them like Mustang turn signals. And if you're doing that or going the opposite direction, if you're, you can actually turn this thing either way, depending on which way you see. If I energize that one, and that one, then it's going to go this way. If I energize that one, and that one, it's going to go the other way. But I can stop it anywhere I want to. All right. Now the number of steps is going to be like if I do this one, it's going to go, and that's one step. See, that goes step, 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 and as this thing turns around, it's going to move that plunger in and out. So that's the idle air controls, like on your GMs and stuff, and little bitty things. And if you ever held one of them in your hand with them plugged in and started the engine up, you'll actually feel it going. When you hold your thumb on it, you can actually feel it bumping it out like a step at a time. And that way, it's got a lot of travel. It can stop it anywhere it wants to stop it, right? Now the transmission solenoid that you got, the variable force transmission solenoid, is like the Ford idle air control. The more current you apply, the more it pulls the plunger against the spring. So it's actually a current-driven thing. Okay. All right. Now before everybody turns into a skeleton in here, including me, I need to move on because this is taking too long. What? Okay, I heard that. All right. That was a yawn, right? That's like the guy that sneezed on Top Gun.
I got sneezed.
Yeah. All right, now, let's see. A stepper motor moves its output shaft in increments. That's true, isn't it? But it's not a quarter or half turn. It's a tiny little bit of a turn, usually just a few degrees at a time. Driveline wrap-up is a term used to I don't call that. Driveline wrap-up is actually called driveline wind-up, so that's a falsie there. It's a term used to describe the proper load on the drivetrain and universal joints when the vehicle is on a slippery surface. That's not even totally bleh. That's a stupid question. Driveline wind-up is whenever you try to operate it in four-wheel drive on hard pavement.
Oh, yeah, that's awesome.
It makes some squeaking noises.
Huh?
It'll make like some funky squeaking noises.
It may do that, and it may just completely stop.
Yeah.
You can actually put the Bronco in four-wheel drive and try to back up, and it'll move about the length of the vehicle, and it'll just stop. And then you can move back, and it unwinds all that, And that's why you got to be. If you're bouncing over rocks and the wheels are spinning and all, that's fine. But unless on the all-wheel drive vehicles, you're going to think, how do they do that? All-wheel drive, that are all-wheel drive all the time. They have a viscous coupling, and they're kind of like a fan clutch, except it's thicker and bigger. So that it has some slippage, but it's constantly applying pressure to the drive wheels that are driving. And so if you got an all-wheel drive sports car or something, you can take those 15-mile-an-hour curves really fast, and it just hugs the road, You've done that, haven't you?
Yep.
They don't drift worth the tube, do they?
No.
Okay.
Not on a Subaru.
Yeah. Okay, using a vehicle lift kit to raise a vehicle changes the vehicle's center of gravity, but not its driveline angle. That is totally false. You know the driveline angle changes.
It changes gravity,
Changes everything.
Yeah, it raises the center of gravity, and the driveline angle changes.
Yeah.
Viscous couplings are tested with a torque wrench. That is true. That's what viscous couplings, what I was just talking about. And now then, so that I won't have used up markers, I will take my markers and put it back in the Discord.
As it do. You can feel the change.
All right. Everybody knows something bad.